In this video, I will explain the layers and the models. So in serial, we could use in the variable and the functions class we discussed above to construct the the entire deep learning model. Actually, in the early day of the TensorFlow, this is the only way to do the job. However, to write everything in this way will to limit our capability to write a very complex model with hundreds of hidden layers. So you can imagine that if we want we need to write everything as a mathematical functions, mathematical expressions, it will be very complex and very hard to understand in the future. So today most of the models are actually implemented by using the layers and the models paradigm. So we will discuss what's the layers and the model paradigm today. So first of all, we can check in an example of the training functions. So we will have the prediction function, which the predict is the model we define. And after we define the models, we need to calculate the loss function. And then we are using this loss function to calculate the gradient of every parameters and use those parameters to update the parameters. Use those gradient to update the parameters in the model. So first of all, we need to clear the gradient of all parameters to be 0, so that we will not accumulate the gradient from the last batch. And then we using the backward function to calculate the gradient. So after this function, the W1, B1, W2, B2, all of those parameters will have the gradient values. So after we have a gradient, so for those items we have a gradient values, we can using those gradient to update the parameter itself. Okay. So we were using the LR, which is the learning rate, to move a little bit, a very small step. The LR will typically a very small values such as the minus 10 minus 4. Okay, so but you can imagine that if we have millions of parameters, which is very possible in today's neural network, we need to call the clear grade function for all of those parameters. So it will in here we have only 4, but in a real case it might have millions of variables, and then we need to update all of those variables by using the gradients we calculate in the backward functions. So this is not very convenient way to do that. Today we are using the layer to group those parameters together. For in the implementation here, we have a layer here, and the layer is only define one variable parameters. This set will hold the every parameter which is assigned to this layer. And actually we are using the setattr method. This is the operator, the override operator, so that this function will be called. We can use an example to explain it. If we, for this line of code, if we assign a parameters to the L1 attribute of the layer. This function will be called. And inside this function, we will first check the value. If a value is one of the parameter of layer, we just add this name, the name of the attribute, into the parameter list. So that in the parameter list, we will have the names for all of the parameters which is assigned to some attribute of the layer object. Okay. So in this way, we can collect the parameters or layers which is created inside the layer class. Then sorry, let me think. Let me find it. Okay, then we could write the function in this way. So instead of calling the clear grades for every parameters, we just call. So before I explain this, I may need to discuss about the models. Sorry, I need to find it. Okay, so this is layer. Actually, for the models, there's nothing new for the models. It's just a class, derived from the layer. So, and we have one more method here, but there's nothing to do with the definition of a neural network. So in terms of the computational graph construction, the layers and the models are the same thing. But we just, so we can say that the model is just the one of the layer. Then once we have the models, okay, we can do the same thing here. So first we do the forward pass, and then we calculate the loss function. Then instead of calling the parameter of every function, we just call the clear grades of the model. And the model is a layer, and the layer will collect all the parameters created inside it. So this will equivalent to call the clear grades for all parameters inside a model. So we don't need to we don't need to write the code in this way anymore. We just write one model dot clear grade instead. Okay. And for the update of the parameters, instead of update every parameters individually, we can use in this for loop to do the same job. Since that the model will collect all the parameters, and then we only need to iterate all the parameters and call the same function to update it. So you might notice that the implementation of a training loop is much simpler after we introduce the layer function. And however, actually we want to make the code more simplified by making the update of the parameter to be one function as well, just like the clear grades. So how can we do that? Actually, we will introduce the concept of optimizer here. The optimizer will be responsible to update the parameters of a model. So that in here, you need to create an optimizer object. So in this example, we're using the Aiden as the optimizer, and we set the LR as its parameters. Then we call the setup function, which will input the model to it, so that the optimizer will know what's the parameters he need to update. So when we call the update function here, okay. So different framework might have a different way to do the initialization of the optimizer, but it always need the two kind of parameter. The first one is some learning rate adjust parameter, such as the learning rate here, or maybe we can have some other parameter called momentum or call some other rates here. And the other parameter is the model or the parameters, so that we can know what's the parameter we need to update by using the gradient. Okay, so but how the optimizer is implemented, we can check the implementation of an optimizer in the D0. Actually, it's quite simple. We need to have the targets here, and we might need some extra argument here, but it's not required. So different optimizer might need different parameters. And the other function is the setup. This is used to assign the target model, so that we will know what's the parameters we need to update in the optimizer. And then there is the update function. So in this update function, we will actually collect all the parameters here by using this code, and then we just call the update one by one here. So for the different optimization protocol or optimization algorithm, we only need to define the different update one function. So let's check. The SGD, which is the most simple optimizer. So in this function, we have an extra argument called LR, which is learning rate. And we just remember the learning rate. And then for the update one functions, we just using the most simple one, just multiply the learning rate with the gradient data and using this to update the parameters, the value of the parameters. Okay, so different optimizer might have a different update one function. For example, this is momentum, so that it will be more complex. I won't explain the detail here, and if you are interested in it, you can check the paper for the details about different optimization algorithms. Okay, but actually, for most of the case, we are either using the ADEN or the SGD for different situation, and okay. So in this video, we have explained some the layers function optimizer in the how they are implemented in the D0 framework. So